La la la, off we go. Oh. Hello and welcome to Practicalli. Thank you very much for joining me. My name is John Stevenson, and this week we're going to continue working on the banking on Clojure project we've been looking at. So writing a web application that talks to a database and simulates a very basic bank. We've got some Clojure specs in there, and add more and more goodness as we proceed. And good morning to everybody. Thank you for joining. I think YouTube's got the wrong time, but hopefully people will catch up. I still have a bit of a cough, but hopefully I shall be okay to go. Right, so if you want to catch up with anything on Practicalli, it's all up there. I've been sponsored again by Clojure Together, so there'll be some more project updates. So that should keep me going to the end of the year, so lots more content coming out. And I've been updating the books, mainly updating web apps book this week, and we'll look at some of the changes there. And again, you can reach out to me on Practicalli, on the community, the Clojure and Slack community, and there's other ways to support me as well. Okay, let's have a look. So we're going to have a look at the Clojure web apps book again. And we've been walking through so the banking and Clojure section. And as I'm doing this, I'm actually trying to extrapolate the kind of the commonality stuff in there and put this into the different sections. So there's going to be like an architectural overview. It's like the generic approaches we're going to get here, and then the projects will have very specific walkthroughs of how to use the libraries and the code that's included in here as well. So I've been doing some updates around the H2 database as well to kind of help visualize what's going on. So we've been using Nextjdbc. We create a connection using a database specification, and that has a specific and so Nextjdbc has a specific way of looking things up, which is defined in the source code. So you look in the source code of JDBC, see that it uses these DB types to look up which driver it's actually going to use. So for H2, it's going to use the H2 driver. And then we've also got MySQL. So it's quite an awful lot of databases very simply. So it just means that you can just include the database driver as a dependency and then just use Nextjdbc as the library, and off you go. It's very simple. So we're also going to use PostgreSQL. They're the same thing. So basically, one's an alias of the other. Postgres is a nice alias for PostgreSQL. It seems to be the terms are often interchanged. And at the moment, we're just persisting data to these MV.db files, which would be useful to know when we're looking at DBeaver, which I'm using to help design some of the SQL. And yeah, we've already covered how to include it in projects, and also added Leiningen as well, in case you're still using Leiningen. And I think, did I add? Yeah, and I've added how to set up H2 with DBeaver, which is a really nice tool for managing databases, which which we'll have a quick look at again today. And yeah, it just sets up using a connection. It'll also download the driver for itself as well. It does that for, it seems to do that for most databases. And and then oh, excuse me. And then you can just browse through the database schema and look at all the values and so on. So we'll use that a little bit later as well. And one thing to note is that if you're trying to use DBeaver and the REPL at the same time to access the database, you might get some like errors saying the file is locked because the convenient nature of H2 database is that you can have it in memory, so that it's very self-contained, it's very easy, so it's a great thing for a development environment, but also it's going to be a single connection, so you need to remember to disconnect when you're using an external database tool. Otherwise you get some issues like this, which is what I did. Let's click on the right buttons. I don't think I did anything for there yet. No. Okay, so let's get back onto the project. So this project's getting quite long. We've done an awful lot of setting up of the application itself and doing some specs. And so we've got the development database set up, and which is using H2, which we've already got defined, and then looking at the database tables itself. So we did cover this last week, but I've basically refactored the database design a little bit, and also improved the code that we're using for Clojure to update the database tables. So that's what we're going to mostly cover today. So we've got these three tables: account holder, accounts, and transaction history. So account holder is basically the customer with the unique ID. Accounts are going to be the accounts that the account holder holds. And transaction history is going to be every transaction that happens. I haven't actually put in any kind of foreign key relationships yet. I'm not sure if I want to or not. But when we build up like the account view, we can go off and kind of, we have the account ID, account holder's ID, then we can basically get all of the accounts that are related to that account holder. And the same thing for a specific account, then we can use the account number to basically say, give me all the transactions for the transaction ID, and they've all got transaction dates, and accounts have a last updated, so we could just say, give me all the transactions from a particular date, and then just add to the existing current balance of an account as well. So I'll try and keep this as simple as possible, but we'll try, I'll put in a few different variations of designs at some point as well. Let's go and jump to the code. There we go. Oops, space. Thinking on Clojure. GG. Yep. So I've also got a design journal, which is a bit messy at the moment, but I'll share this on the GitHub repository as well. It basically covers all the kind of design decisions I've done. So it's got some useful kind of background information, which I'll also surface in the book. But essentially we've got our namespace. We're including, to start with, we included the Nextjdbc library, just to be able to use all the functions from that library. We'll talk about the other two a little bit later. And I've simplified the database specification thing, so all I'm just doing now is just having a database specification, and this is just for dev. And so for Postgres would include another one of these for production. And so this is just basically a name that represents the hash map that defines the database specification for the H2 database. I do have a data source, but I've changed the way that I'm accessing the database, so we'll see that that's no longer useful. So I did have like a database source, which is handy when you're just building up things in the REPL, but when we're doing things properly, then it's not needed as much. So we've been kind of pushing just using where is it? Oh, I've changed all this now. Yep. Yeah, so I was using those the DB the data source directly with the execute commands, but I've changed it now. So the database schema, I've cleaned this up a lot, and so we're basically just defining the three tables here, and I used DBeaver to actually generate a more specific kind of SQL statement. I'm not an expert on SQL by any means, but this is kind of seems to be a more consistent approach, and I was trying to get a consistent approach for across databases as well. So I'm using DBeaver as a way to generate all the SQL statements properly. So I'll create the database schemas initially in the REPL, and then I'll get DBeaver to actually just generate it. So these are all created. If we fire up DBeaver, pretty quick. And so I've already added several database connections. Oh, there's a new version. No, I'm not going to upgrade live. That would spell all sorts of disaster. So there's a sample SQL database in there. This is the Postgres database, which is live. So it's live on Heroku. So that's the one I created, so that's fairly easy to add. And then I've got the banking on Clojure. So it's basically just using, it's a bit small, but you can see it's using the mv.db database. Can we look at this? Edit connection, there we go. So it's basically using the driver that it downloaded itself, and I just basically added the path to the banking on Clojure mv.db file, and that was it. That's all I kind of needed to do. Yeah, so when I initially created create a new connection, there's lots of different databases in here. It's a new database connection, and then you get to choose from all the different kind of ones. So the H2 is in the embedded section, and then there's like no SQL, and then there's all sorts of other ones as well. Azure SQL, interesting. Oh, there's H2 there as well. Popular. Oh. Apache Ignite. There's loads of ones I've never even heard of there as well. So it's very easy to kind of connect to anything. So that's all I did for that one. And you navigate to the tables, view tables, and you also view the entity relationship diagram as well. And one of the things I did was basically to go in here and go into accounts, and you can generate SQL from that. So you can generate SQL statements. So if your SQL is a bit rusty, it's still very easy to do that. It saves you going off to W3 Schools and finding out things. I've just been pulling out like DLLs, the DDL language, and then just copying these into the projects. And that seems to be a nice way to create legitimate looking SQL for me. Okay. Before I forget, so once you've so when you're opening these in DBeaver, then it's going to connect to the database. So I always remember to disconnect and then that doesn't interfere with me using the REPL to do things. So we've got the database schema, we've got the schema to create account holders, and this has changed from last week as well. So rather than defining the whole connection in here, I've just defined the specific SQL statements. And this is quite useful, I think, because if when we move over to something like Migratus, which is a better at kind of managing changes over time over a database, then we should be able to just copy these defs into Migratus and use them there, because it's just the SQL statements themselves. And one thing to remember is that when you're for Nextjdbc, you need the string of the SQL statement, but it also needs to be in a vector. If you don't put it in a vector, then Nextjdbc gives you a nice little warning. So we've got that for account holders, accounts table, and then transaction history table. And so I don't think I've changed anything else. Oh yeah, I've just changed the way that we had the primary key, so I'm just using this constraint. So we define all the column names here, and then adding a constraint to specify which of the column is the primary key. And so when DBeaver generates this, it gives it a kind of random constraint name. So I've changed that to something very specific. So this constraint is applying a primary key to the account holders table. So I've called it account holders primary key. And this means that if there are any issues, any kind of errors from using SQL, then if it's to do with the primary key, then it's very clear, because the constraint name is telling me that it's the account holder's primary key. And so it makes diagnosing databases a little bit easier. That's something that the DB administrator will be happy that you're doing, especially if you're the DB administrator. So I've done that for all three of them. So this has got an accounts primary key and a transaction history primary key. Oh, we've got a little note there to remind me. There we go. So that's it's kind of nice looking SQL defined. And then we've got some helper functions to actually run this SQL, because we're no longer running it from the defs. So previously we had a def, we'd evaluate the def, and it would create the connection. It would then run the SQL and create the database table. This kind of separates the concerns out a lot nicely. We've just got the SQL schema, and then we can decide what to do with it and how to actually execute it. So these helper functions, we've got a create tables. I'm not too sure about the name of this, but it'll do for now. So it kind of, what does it do? It just creates tables. So it's going to establish connection to the data source, and creates all the tables. So I guess it should really maybe be create all tables. Yeah, you can just use it to create a single table as well. So we're going to create a connection, but we're going to do so in a better way than we were doing last time. And we're also going to make sure that the database connection is closed, which is also very important. And arguments it takes a table schema, which is a vector of each SQL statement. So basically it takes each one of these. So the vector of the string of the SQL statement. And it also takes a specification. stuff. There we go. So the arguments, and it's not actually going to return anything. It's a bit of a side effect. I could actually call this create tables exclamation mark. It doesn't make any difference in how it works, but it does give an indication that it's doing a like side effects works, because we're basically just updating, changing the database, changing the world. So it's convention to put bang in there when you're changing the state of the world. Let's put that in there for now. I'll update the code as I'm going along. Just remind me to update the code when I'm calling this. Boom, there we go. Have we got the repl running? I don't think I actually have the repl running, because I think I restarted. Yes, there we go. Oh, there we go. So the create tables is basically just doing a JDBC execute for a transaction, which we'll come to. So it's basically a connect. We've got a connection. There's a transaction that's within a transaction, and it's going to run an SQL statement. So not really doing anything different logically, but how we do things is a little bit more involved, although it's still fairly straightforward, hopefully. So we've got with open. So with open is going to basically manage our resource. In this case, our resource is the database connection, and you can use with open for any kind of resource you want. It's usually focused on a single resource. And so it makes sure that when you've used the resource, it's going to automatically close it for you as well. So you could use it for file access as well. And so basically, with open has a scope. So within the scope of the with open, then the resource is going to be open. But as soon as you leave the scope of that with open, then the resource is automatically closed. So you can't really use a lazy evaluation around with open, because it will have closed the connection before the lazy expression has evaluated itself. And so we've got with open, and so we're defining, so it needs a binding. So we basically bind the local name connection to the JDBC get connection function, which we just pass the data spec. So that's the specification we've got up here. We just pass that in, and that creates a connection to the database. And so that's the connection that the with open is going to manage. And we could just use that. We could just use the JDBC execute connection and then the SQL statements. But we've also going to potentially do the database creation all at once. So we've got 3 different SQL statements to create the 3 tables. And so I've also set this up to happen within inside a transaction. And so either all 3 database tables are created or they're not. So it just basically doesn't create any of them within inside the transaction. And so therefore we're doing, so we've got this JDBC with transaction, and it's a bit like with open. So we have a binding. So we basically bind the connection that we've got above to its transaction local name. And then we can use that transaction to basically have a transactionable connection. And so, yeah. But then I've got, if I want to pass all three, or if I want to pass multiple table schemas, then I'm going to have basically a, where we jump down here, rather than doing a single create table, I want to be able to create all three tables. So I'm basically passing in all three tables as the table specifications, and then I'm just using a doseek to basically iterate over the table schemas. So I've got three table schemas in table schemas, and so what doseek is doing is going to pull out each one in turn, bind it to SQL statement, and then it's going to run the next expression. So that's basically using the transaction with the first SQL statement, and then it runs. So let's just let's see if we can see that in action. If I drop these, oh, maybe it is. Oops. Do I need? Oh yeah, I haven't evaluated everything. So if I just started the REPL, let's just evaluate things. Create tables. I did evaluate that. There we go. Oh, yeah, so I didn't evaluate drop table. That's why it wasn't working. There we go. So I just got this little comment-rich comment block that just helps me manage the database schema as I'm evolving the design. And it's quite useful to keep this in this namespace for prosperity, so people can come along and actually use the functions and see the arguments and some of the kind of suggested argument values that can be used to drive this particular namespace. So for example, we can show schema and drop schema. So I think, yeah, so it's already showing me the schema or all the databases that are already there. But I can go in and drop the databases. Boom. Oh, that was working, I'm sure it was. What have I done wrong here? What have I done wrong? Oh, yeah, I did that last time. So rather than data source, because I think previously I was using data source, which doesn't work with Open. It wants an actual database connection. So let's change that. Evaluate there. Yes, there we go. Yeah, so that's the difference with Open. You're not creating a data source, you're creating a data connection specifically. So then with Open is just going to close that connection, and then we can drop. There we go. Oh yeah, so it's not there. Oh, I did kill them anyway. Okay, cool. So they're not there. Yeah, so you can check that the schemas are not there because it's returning an empty vector. When something's populated, then you get a vector of maps, and each map is defining each map is a Clojure hash map of the table schema. So we've got our with Open inside a transaction doing a doseek, so it's iterating around three table schemas. So if I just switch the debugger on, you can see what's happening. So this is just putting breakpoints inside the create tables function. So whenever I call create tables, it's going to step through that. So I've got a create tables call here, except it's now called create tables with an exclamation. There we go. And you see that's now also highlighting the fact that the square box means it's got a debugger around it. So I'm going to do some debugging when that happens. So if I evaluate this, then I'm going to walk through the code, and so you can see it's got the database specification, which is the H2 database type. And that's passing into get connection, which gives us a connection. So we get a connection object. And then we use that connection to create a transaction. And then we've got our table schemas. So this is you can see it's a vector of vectors, and each vector is a string, is the SQL string. And then so we're going to execute the transaction on a specific SQL statement. So we're just taking the first vector. So this first, this is basically one of our defs that we have for the SQL statement. So this one's going to create public account holders, and then we get the results from that. So and then it'll go around, still using the same transaction. We get the next SQL statement. We run that, and the transaction, and the third, and that's the final one. So that should be the end of this. So that's the result, and should turn in nil because we don't actually, doSeek itself is a side effecty function. So it all it's doing is just doing something and just returning nil. It doesn't actually do anything of itself. It's just causing something else to actually happen. And then once it's finished, then it's going to close out, and the with open is going to basically close the connection for us and make sure everything's tidied away. We could also use run as well for this, but I think doSeek tends to be more common, but run seems to be a bit more aesthetically pleasing to me, but it doesn't really. I don't think for this case it doesn't really make an awful lot of difference. So I hope that's clear. There's no questions in the chat. So a simplified version of that is what we've done for the show schema and drop tables. So these aren't using transactions because they're only doing one. I'm only assuming we're doing one specific SQL statement, and that's kind of hard coded inside the actual body as well. So here we're just taking a database spec and a table name, and it's going to create a connection as before, just using the DB spec. We get a connection inside the with open, and then it's going to execute on that connection. And then we're using str to build our SQL statement, and so that's using basically pulling in the argument table name, and so basically just showing columns from, and then it prepends table name on that. So we've got a string from that. Did I know? Oh yeah, it doesn't know what table name is, does it? And then it just executes that SQL string, and it's a string again with inside the square brackets of a vector. And one of the things I found quite useful when I was doing this was, I'm just going to jump to the bottom of the file. So if I actually forgot to put the square brackets in, so if I forgot to wrap this in a vector, if I just delete that for now. So now it's just going to create a string. It's going to use a string for a connection. Yeah, it's still the old one. So there we go. So evaluate that. So this is not quite right. And so if I do call show schema, so let's just show schema on here, F. Then we get JavaLangClassCastException, which kind of is telling us that we're using a JavaLang string. We're trying to cast a character to a JavaLang string, which doesn't really describe what the actual problem is. So it's, I mean, I know what that means because I know what the error is already, it's something that's very easy to do. I've done it a few times. Is to forget to put the SQL statement string inside a vector. So it's basically trying to, I think it's trying to take the first. It's almost like it's trying to take the first thing from the vector, but there's no vector, so it's actually treating the string as a vector. So it's going to take the first character as the actual string, and therefore it's causing an error. But I only understand the error message because I understand what's going on. You can get more help with Nextjdbc if you go and let's go to the top. So you include the Nextjdbc Specs, then this will include all the Clojure .specs specifications. So I've just aliased that as JDBC spec. And then there's a couple of functions, one to instrument and one to instrument. So we can instrument all the JDBC functions, which basically means that they'll all have their specs attached to them. So when you call a function, you get not just the Clojure error, but you also get any conforming errors from Clojure spec as well. So if you call a JDBC function that doesn't have with the wrong argument, then you'll get like a spec error as well as the normal Clojure error. So if we just evaluate that, so it's basically adding these are all the functions that it's basically instrumenting, and so it's basically just a long list in the Nextjdbc source code that shows you all the functions it's all the namespaces it's actually instrumenting functions from, which is pretty much most of them, I think. And so now if we go back to our code where we were showing tables, where is it at? Nearly there. There we go. So now if we evaluate this with the functions instrumented, then we actually get more information. Oops. So we're getting a spec assertion failed. So this is showing us the fact that when we try to call, basically try to call this execute function from, where is it? Oops. Yeah, there it is. Cool. So when we called execute, JDBC execute, that's from Nextjdbc, then one of the arguments has failed, so it's not fairly on the connection, but it's fairly on the this particular value. So we can see the value it's passing in, and that's a string of the SQL statement, but it's not in a vector. So it's very easy to see what we're passing into the JDBC execute. And it's saying that it's failed because it's not satisfying the vector predicate of the specification. And it's telling us where the spec is, so we can actually go and have a look at it if we want to. And yeah. So that gives us a lot more information and actually just highlights. So we can have a look at the spec, and you can see that the spec says we need to provide a vector. It's looking for a vector, and so that should hopefully remind us that we need to put our strings, SQL statement strings, inside a vector. So that provides lots more information. So using instrument when you're developing is really useful, and then when you've finished developing, you can just close the REPL, because I've just put these in again another rich comment block. So even if I evaluate this entire buffer, it's not going to instrument things unless I actually come in and manually evaluate these lines. And then I can decide to just, oops, what did I do? And I can just uninstrument them, or instrument them, and it's not there. I don't have the checks anymore. So if I wanted to kind of play around with things and not have the spec errors, then then I'd switch them off. Boop, boop. Okay, and so what are we doing? Yes, okay. So using the specs is really good. It's a nice example of using Clojure specs. And I think pretty much all the, at least all the public functions that you're using from Nextjdbc, you've got specs on them. So it makes it a lot easier to work with. Oh, I should probably put this back before I forget. So let's rub that with a boop. There we go. Magic of Vim. There we go. So we've got our show schema. We've got tables. We can see the tables. Did we put the tables back in? That's a good question. I think we did. Yes. There we go. Yeah. So we can see we can always see whether we've actually got the tables loaded or not by just evaluating the show columns, show schema. So that's all the table design sorted out. And so I'm working on the queries and create queries again. So if we go and have a look at DBeaver, so we can just expand this, public tables. I couldn't figure out a way to change the default font size for everything, so it's a bit small, unfortunately. But if we go into account, then I can actually go in and generate, select and insert things. That gives me the kind of basic insert code in there as well. So I can actually use that to copy that and then just use that as a basis for creating the SQL statement in using Nextjdbc. Let's go to yeah, so we've got the DDL from DBeaver, and that's pretty much kind of what I've been doing here. This is a bit messy, it needs cleaning up, I'm afraid. But yes, yeah, there we go. So this is what we're going to be working on this afternoon. But basically, we've got we're opening another connection, and which is just the same as what we've done before, and then executing on the connection, and then we've just got the string builder. So it does start to get a little bit messier the more complex our SQL statement is going to be. But this does work, I think, as far as I remember. Let's just check. So that's working. So we're basically just calling, we're persisting account holder, we're creating a connection, we're going to pass it the DB spec and the account holder ID, which we're using string to basically inject into the SQL statement, so we can create a new a unique account holder ID each time. So we call this, and so then we're just basically calling that with just generating this random UUID, just for testing purposes really, and then we're passing the DB specification for the database. And so if we call that, oh, the file is locked. I told you that would happen. And then I remember to go off and disconnect that. So there we go. And so now the connection from DBeaver to database is no longer there. Oops, come on. Oh, we've got caps lock on. There we go. So we've got a function, call a function, and it's got it's an update count of 1, so it's actually updated the database tables, and with a new account holder, and we can do that a bunch of times. Yeah, so each time it's doing one. So you can do we can use the generic execute JDBC execute function. Again, it's just executing a SQL statement. But it's going to get quite messy. The more we need to inject values into this SQL statement, the more messier it's going to get. With the more kind of parameters, more arguments we need to pass to this function. So that's not probably the most ideal way of doing things. So I've refactored this a little bit. So we've got our SQL as a def, and so that again that makes a nice little separation. We can kind of make these as messy as they want to, and it's all abstracted away behind a name. And here we're just putting in the Java util random UUID, and then we can have a more generic insert record function. Although actually we just make this a generic update DB kind of function, because it's doesn't have anything specific. There's no specific SQL statements in here. It's just using whatever SQL statement we pass in there. So it's a bit more generic, a bit more usable. And so all this is doing basically is just wrapping around with open. So it's wrapping around with open around the connection, and just making sure that we're always closing the connection afterwards. And so then we can, so we're passing in DBspec, the table name that we're going to update, and the SQL statements. So yeah, do we need the table name? I'm not sure why I've still got the table name. I don't think I actually need that. No, it's not being used. We don't actually need that, do we? No, we'll simplify that. There we go. Because it's all self-contained inside the SQL statement, so we don't actually need the table name. Does this actually work? Let's see. So, yeah, I haven't changed anything there. Oh, am I doing? Yes, there we go. It's not data sales, data connection. There we go. I've done that quite a few times now. There we go. Oh, I've violated the unique ID. There we go. Yep. So it's using the same. Yes. Of course. So one of the disadvantages of doing this is that because we've got the random UUID inside the def, then it's only going to call this once. So it's not actually generating a new random one each time, because once you've evaluated the def, and each time you use the def, it's just using the same value. It's not caching, it's not re-evaluating the random UUID. It's going to actually replace this with the result of this inside the def. and so it's going to be a fixed value each time. So that's the that's kind of the flow of that. But this is still, whichever kind of refactoring we do, whichever approach we do, is still having to, it doesn't solve this issue of having to like do a string building of your SQL statement. And there's nothing in Clojure really to help you kind of manage these strings nicely. But luckily there is something in Nextjdbc that helps with this as well. So we can use, rather than using this execute statement, we can use specific what the author terms as friendly functions, such as insert, query, and so on. And we can use Clojure map to build our strings. And to me, this is just so much nicer, because first off, it's a map. Yay, I like maps. And so we can use all the Clojure tools to inspect it, to build it, to create it. So it's a lot easier to generate these kind of maps as well. And if you remember, if you look at it closely enough, it looks very closely similar to the specifications that we've created, except it's got like the names are slightly different. So we can use the map with insert, and insert will basically create the SQL string for us. So we don't need to do any kind of string munging around there. So I think I was doing this last night, so I think it works. It does work. Yeah, there we go. There we go. And see, we're getting a different UUID each time. Yay, there we go. So it's just populating the database. It's a very easy way to populate a database with lots of dummy data, and test out the design of your tables and so on. So if we look at, I think there's a whole page of, oops, where are they? There we go. Friendly. If you look at the friendly SQL functions, so if you go to the Nextjdbc getting documentation, there's this friendly SQL function section, and we've got insert, query, update, and delete. So I'm going to add all these, and then that leads on to kind of using things like Honey SQL as well, to having a full composable DSL. So if you're going to do an awful lot of SQL, then using Honey SQL is going to save you a lot of grief, especially if you're more comfortable writing Clojure than you are writing SQL. And you could, of course, just go and write all your SQL in DBeaver. There is an SQL editor in there as well. So you've got that option, and then you just export those and put them into your Clojure or into your project somewhere or into Migratus. And that makes it a lot easier that way. But it depends. So you've got a choice about whether you want to write lots of SQL or you want to write Clojure. So that's quite nice to have those options. And there's a few other libraries which are kind of interest there as well, but I'm not going to delve into those. We're going to look at Honey SQL and see how that helps. But other than that, that's it. And the other interesting one is if we want to insert we want to have multiple inserts, then it's quite nice, simple kind of approach to doing that. We can kind of just have a vector of vectors of our data. And so what we're going to try and do is generate, using the specs from banking on Clojure, and generate like a sample set of data, and then just use insert multi to put that into the database. Yes, there's a lot of things I've found over the last few days. So this is all kind of like the way we've been using Nextjdbc is quite the low level, and so now we're kind of moving up some nice little abstractions piece by piece to make it easier. And so definitely the The friendly functions are nice. There's also like result set builders to look at and prepared statements. And we've covered transactions. The only thing I think we're going to cover a little bit more about, well, the only thing we're going to change with the transactions is, I think if we go back to the create tables, then the only difference we get in our create tables if we're going to use, we're going to change is that when we, if we use connection pools, then we already have a connection, so we don't need to do the with open. We can just pass in a, we can basically simplify this function a little bit by just saying, just use the transaction and pass it the connection from the connection pool. So we don't actually need to kind of get the connection and create a new connection, which we're doing essentially each time with open. We're creating a new connection, doing some work, and then closing that connection. With a transaction pool, we can just dive in straight at the JDBC with transaction and supply connection from the connection pool and do that as well. There's some more stuff in the, if you want to do more things with the transactions, there's a section in the front page of the Getting Started guide that covers transactions. Where are we? Oops, didn't want to do that. We want that one. There you go. So it kind of shows you, you can mix and match. You can have things inside with open, and then you can have things that are committed straight away, things that are committed inside a transaction, and then things that are committed after a transaction. And that's quite, yeah, quite a flexible approach. I'm not sure if I'm going to use prepared statements. I don't think we do that much to do that. I might do one just for an exercise. And I'll have a look at plan as well. Yeah, connection pooling. Here we go. So if you like set up a connection pool, then we could just use that with the yeah. There you go. I was using that with open, but I think you use that with. I think you could use that with the transaction directly, but we'll see. I'll give that a try as well. But that's quite nice. So rather than kind of specifying we're specifying a data source that is the current connection pool. It's just using a type hint just for a bit of efficiency, I think. Cool. So we'll have a little play with this as well. But the next thing is mainly to kind of finish off all the SQL, so we can get data inside the database, and then start hooking up our web application handlers to call those functions and pull out data from, well, put data in and pull out data from the database. Okay. Right, well, that covers it for today. I'm going to do a lot more work next week. If you've got any comment suggestions, feel free to reach out to me on the Practicalli channels and Clojure in Slack. You can send me an email, or you can send me a direct message if you don't want to ask stuff in public. And yeah, that's it. Hope you have a good weekend, and see you next time. Here's the buttons. Boop, boop. Thank you very much. Might have a shave by then. It's a COVID beard. But again, thanks very much for joining, and see you. Goodbye.